Okay, continue with this section 3.6. It's a long one, guys. I'm so sorry. They introduce another concept that is the elasticity of a function. And they relate and they bring that concept that is from economic. Just to give you a little bit of a ground, the elasticity is something that is coming from physics. Okay, basically what it's telling to you is how a piece of material is deformed when you apply some stress to that material. But I'm not going to really go further in that because there are so many concepts already and I don't want you guys to get confused. In this case, elasticity it refers of what is the percentage change of a demand in the market of some items respect to the changes in the prices of those items. Okay, for instance, let me remind you about the example that I gave you, I don't know, 2 lectures ago or something like that, about the price of the oil. So if they observe that between the price of the oil 2 months ago in April, okay, and now in July, the price of the oil changed in 10%. So they say, well, based on that, what I expect to have in the demand of the consumption of gas or the consumption of oil, or what is gonna be the demand of oil if I have a change in the oil price in the market. And that relationship is what they call the elasticity of the price. Okay, so in the example, for instance, that you have in your textbook, and I screenshot that for that reason, they say the elasticity of the price in this particular case, in which they observe an increment of the prices of the gas in 10%, well, they ask to themselves, well, if there was an increment of the gas of 10%, what is going to be the implication of that in the demand of the gas in the market? And they got that the percentage change in the demand was 15% based that the price increased in 10%. And they made that ratio. And when they made the ratio, they got negative 1.5. What is the meaning of that? The meaning of that is that if I have an increment in the price of the gas, the demand of the gas is gonna change 50%. But they are giving to you more information than that. They said that it's negative. What is the meaning of that? That the demand is going to decrease. In which amount? In 50%. That is the elasticity of the price. So the mathematical definition, okay, of that elasticity of the price is the derivative of the demand respect to the price multiplied by the price of the item divided by the corresponding demand of that item in the market. That is the elasticity of a function. Okay? So we're going to have exercise of that. In this example that I'm giving to you, this is the example that I comment in the previous video. This example is taken from your textbook. Let me just bring the textbook here. It's a little bit, that's the one that I want to tell you that it's a little bit complex. I opened the wrong icon. So it's this one here. So in your textbook is the exercise 33. Okay, I'm not telling to you that you need to make the exercise from your textbook. Okay, the exercise that you need to make are the ones that I'm going to give you. But what I want to show you is that I'm taking examples from your textbook. I mean, I'm not taking examples from any other source. So is this exercise? They say the demand or elasticity. And here what we have is the following. Let me just make it a little bit bigger this. Okay. Based on sales data over the past year, the owner of a store of a DVD store devices, I mean, this owner sell DVD devices, the demand function based on price is given or modeled by this linear function. Okay, so that is the demand. So we can see that is a linear function, but the slope of the linear function is negative. It's -2. So what is the meaning of that? That as the price increase, the demand is going to decrease. Okay? If I have items that in the market are getting higher, higher, and higher, well, probably the demand is going to decrease. I'm not going to purchase that item because it's getting higher the price. That's what this is telling to you. Okay? And this demand, that is the number of DVD that can be sold in one day, I mean the number of DVD that store has been able to sell in one day, is a function of the price and follow this linear function. And what I did, I normally use, I like to use Desmos, and I graph that function. Okay, of course in Desmos I cannot use P. If I'm going to use P, I need to define that, and I am a little bit lazy, I didn't make that. Okay, so what I did was just, instead of using P, I used the normal and current variable X, but X means in this case the price in dollars. Okay, what in your problem you have as the letter P. Okay, the lowercase letter P is going to be represented here by this variable that is X. Okay, so this is the demand function, okay, for a numbers of DVD that is sold in that store in one day based on this price, that is in this case X. And I run that between, I don't know, $0 to $25. Okay, and this is what I get. So this red line represents this linear function. And as you can see, as I told you, this linear function is a decreasing function that decreases in a constant rate of -2, right? Based on the price. That's it. And they say, well, according to the model, how many DVDs can be sold in a day at a price of $10? Well, we need to use the model. So what I'm going to do is just to plug $10 in here, and the number of DVD that I can sell, the maximum number of DVD that I can sell in one day, if the price is going to be $10, is going to be 40 minus 2 times $10. That is going to give me 40 minus 20, that is $20. And that's what I have here. So if I'm going to the demand function, I have here $10, and then I look what is the price, and that is going to be $20. Okay, the price, I'm sorry, the demand. So basically, if the price is going to be $10 in one day in that store, according with this model, we're going to be able to sell maximum 20 DVDs. Okay, this is what this is telling to you. Okay, they say, well, find the elasticity function for this demand function. Okay, what is the elasticity function? Remember the concept. It's going to be the derivative of the function respect to the price. I'm going to use here, it's going to be let me use this one here, the derivative of the demand function respect to the price of selling those DVDs multiplied by the price, which is the independent variable, and divided by the demand function, which is function of this variable. So if I made the derivative of the demand function respect to the price, it's going to be the derivative of this one. The derivative of this one is going to be minus 2. We know that, okay? Because it's the derivative of this linear function. And the derivative of the linear function is just the slope of the function, which is in this case minus 2. Then I'm going to take the independent variable, which is the price, and I'm going to divide that by the demand function. The demand function is 40 minus 2p. Is 40 minus 2p. Okay? So this is going to be the elasticity function of the prices of selling DVDs in this store. That's what you have over here. Minus 2p, in this case, is s divided by 40 minus 2x. Of course, we can simplify this because 2 is a common factor. So we can have here minus x, and then here is going to be 20 minus x. Okay, which is exactly what I have over here. But I just leave it like this just to remind you where this is coming from. This is coming from for the definition of elasticity of the price. And what I did in Desmos, I plot that function in here. And you can see that you have two branches. Okay? Now, let's take a look of this function. So, and let's go here with the comments. So they say, find the elasticity function for this demand function. Well, we know it's this one. The next one is D. For what price is the demand elastic or inelastic? Okay? Oh no, I have here another one. According to the model, this is B. That is very important. According to the model, what is the maximum price that can be charged above which no DVDs can be sold? So what they are telling to you is look at the demand function and look at what price is the maximum one that you may have, in which if you put that price in the store, there is not going to have any demand. In other words, you are not going to sell anything or to sell anything. Well, that is when the demand is equal to 0. Well, that maximum point, that maximum price is $20. If I make a price of the DVDs greater than $20, I'm not going to sell anything in the store. I'm not going to be able to sell any DVD in the store. It is already $20. The demand is going to be zero. The people is not going to purchase anything. But it's even higher of $20. I'm going to start losing money because the demand is going to be negative. So I'm going to start losing money. So the meaning of that is that the demand function doesn't have any sense when the price is greater than $20. So I'm going to forget about all the prices greater and equal than $20. So that is not a business, a deal for me if I am the owner of the store, because I'm going to start losing money. Okay, so really the branch that I need to have is between a price that goes from 0 to $20. And actually different than $20, because if it's gonna be $20, okay, the elasticity price is not going to be defined in $20. That is another point. Okay, now let's move forward. They say the following. Okay, so look at here. For what prices is the demand elastic or inelastic? This is the reason that I made reference at the very beginning of this section of physics. This is a concept that is coming from physics. Okay? The point is that a material is elastic when the deformation of the material, when I apply some force over that material, is linear. Imagine that you have a string and then you stretch that string, so you apply some force to your string. The enlargement of that string is going to be a linear function of the force that are applied to the string. When we have a material that responds to the force in that way, we say that that material deforms following an elastic behavior, a linear behavior. So bring that concept into the economics is telling to you that the elasticity price, or the elasticity of the price, we need to look what is the range of price in which the elasticity is gonna behave like a linear function. So let me make here a sketch. So for instance, okay, here, if I'm here, the elasticity is not going to be linear. Actually, the elasticity is more like a parabolic function. You see, follows a trend that is no longer a linear function. But if I am here, and let me use another color, let me use red here, and I'm going to use this line, dashed lines. So within this range of prices, the elasticity is almost linear. Between what? Between 0 and almost 10 in this range. In this range, the black curve have a trend behavior that is almost a linear function. Okay? So the answer for this one, for what prices the elasticity function is elastic between 0 and $10. Okay? And when is gonna be inelastic? Well, from $10 above is gonna behave like the blue curve that is no longer a linear function. So in that range, it's going to be inelastic. Okay, perfect. So let me just erase this for a moment and go back to the original functions that we have. So, well, we compute the elasticity, and again, I use Desmos to plot the elasticity, which is this function here. So the elasticity basically is decreasing with the prices. Okay, so they say here, let's go to F. If the price of DVDs is rise from 10 to 10.25, I mean, I have a change in the prices that was what? That was 10.25 minus 10 divided, all of this divided by the original price that was $10. And then I compute that in percentage. That is what? That is 0.25 divided by 10. That is going to be equals to 0.0025 cents. Okay? So if I change the price respect to the original price of $10 in 0.025, and that in percentage is to 5%. In other words, if the change of the price was to 5% from $10, what is going to be the change of the demand, the percentage change of the demand? Well, what I need to do is to plug this 0.025 here, is to plug, I'm sorry, $10 in the elasticity function. Is evaluate the elasticity function in the price equals to $10. Okay? When I made that evaluation, what is give me to me? Is give me to me -1. Okay, what is the meaning of that? Well, if I change the price from $10 to 5%, the change in the demand is going to be 1 times to 5%. And that is going to be minus to 5%. What is telling to you this? That my demand is going to decrease in 2.5%. Because this number, what represents is the change in percentage per 1% of change in the price. So if I have that the change was 5% in the price, then the change in the demand is going to be this 1% times the change of the price, which is 2.5%. The -1, what this is telling to you is that the demand is decreasing, which is what this model is telling to you. Okay? Well, this is the example that I want to explain in here. And in your notes, well, I'm going to include some other example for this one to give you the opportunity to make this exercise, to make exercise of elasticity. Or probably what I'm going to do, I'm giving to you all the numbers here. What I'm going to ask you is to put all the details. How do you derive all these answers? Well, that's what I explained you in this video. Okay, thank you.